everyone. I'm here today to talk a little bit about observability, more specifically our journey towards observability. So, yeah, just a quick introduction. My name is Daniel Silva. I'm a product engineer at CoverFlex. So at CoverFlex, we aim to provide flexible compensation for modern companies. So it's pretty cool stuff. And it's my first time in person at ElixirConf, so it's been pretty exciting so far. Cool. So today's agenda, first a little bit about the context, and we'll try to understand what observability is, the steps that we took towards observability, and after that I'll talk a little bit about our custom tool, and followed by the next steps and some Q&A at the end if you have time. So I was fortunate enough to join CoverFlex almost like 3 years ago at the very beginning of the company, and that allowed me to watch the startup grow from the ground up. And for me, it has been a great privilege to see it grow like that. It gives me great perspective. It's really nice. And you probably, most of all, know how startups work. It's go to market fast, deliver fast, iterate quickly, and finding the product market fit for the company, it's crucial, right? So on this very fast environment, and with the product being developed to a more complex product, like in a very fast rhythm, your product gets complex and your system also gets complex, right? And thankfully for us, the usage of the product kept growing very rapidly. We could see increase of new users pretty much every month, every week, and not only on new users, but also on existing users, right? So existing users would do more card payments, do more reimbursements through the web app, the mobile app. And yeah, that's cool. That's good because it means more money, right? But it comes with some interesting challenges. Having more people use your product actually increases the surface area for those weird edge cases that happen in production, right? Performance issues, all those cool stuff. So with the system getting more complex, things tend to get harder to understand. And with the increase of this surface area, the operational problems become more frequent and novel, right? New situations might arrive every day because some weird edge cases that might appear. So I like to say that this process is a lot like mountain climbing, right? At the beginning, it's very easy. The ground is very flat, it's very nice, but as you get going, as you climb up and up, it gets harder. And if you don't have the proper tools, it gets even harder, right? Cool. So where we were some time ago when climbing this mountain, right? So this was like the state of the art some time ago. So, and this probably, you can relate to this. Debugging was mostly done via text logs, and we are accumulating that on our logging backend. And the queries on these logs were rather painful because we needed to do full text search, and getting to the desired place was not straightforward. So when we realized that, okay, maybe we don't have, the existing logs are not enough, then we need to add more logs, right? And ship it to production. So who here has done that? Yeah, probably the ones that didn't raise their hands, they're lying, right? It's something very common. And that's actually as an hidden cost, right? Because you add the logs and you need to ship it to production. And if you have a very low frequency of releases, that change might only hit your production in a week, 2 weeks, or a month. And yeah, that might be a problem. So in that meantime, your clients might be suffering from that problem. And when you go back to investigate, you need to context switch, and that's even worse, right? That's a problem. So it's not just adding logs. So it goes deeper. Besides that, we relied heavily on monitors and alarm for known problematic situations. So this is okay when you actually know the problem. So if you don't know, you are in big trouble, right? So you just know when your customer complains, right? And then debugging by intuition or randomly guessing stuff. So you might see the problem 1 or twice, and based on some random symptoms, we just got used to it, got confident, and then we just guess what might it is. You see the symptom and just guess. This has a major flaw because the same symptoms have different problems, and that's not good. And also, kind of tied together to this, Some people were like gathering this experience because most of the same people got to solve these problems. And we are concentrating all of this knowledge on these people. So if you have that hero guy in your company and he gets hit by a bus, that's bad for the business, right? So yeah, we wanted to change that. Okay, so we wanted to change how things were done. So okay, let's try to look into this observability stuff. And yeah, there's a bunch of good resources out there. One that really helped us was this book, this Observability Engineering, from charity majors, Liz Funk Jones and George Miranda, where they are actual experts on the matter, not me. But they have this very well explained. And one of the things that they do is explain, okay, so we are probably used to the traditional monitoring thought process, right? We have alerts and metrics, and when things go wrong, we get notified, and I go after the issue, right? It's mostly reactive. On the other hand, observability, basically, you have all the data available that you need, and at any point in time, you can slice and dice and find the root problem of the problem. So this is mostly based on questioning and understanding and investigating, right? So the building block observability in the book is what they call the structured event, right? And you can imagine the structured event like a key value pair map, right? And it has two interesting properties. One is high cardinality, so high percentage of unique values. You can think about them as like user ID or request ID or IP addresses. So unique values that allow you to perform a granular search through your data, right? And then high dimensionality. So as big as this map is, as much context you give to this map, you can ask more and more queries, different questions, and get different answers. So this seemed to make sense to us, right? It seems like a simple concept. So where do we go from here, right? So I thought about it. Okay, let's look at logs, right? That's the first thing that kind of popped into your minds. So these are the default logs for a Phoenix application, right? They're fine. We can read them. It's okay. But they are unstructured, right? And we usually ship these logs to an external service. And it's not very straightforward to process them. So, okay, let's turn these unstructured logs into structured logs. And yeah, thanks to the community, there's already a library for that, this logger.json library, that has a really simple configuration, right? And the important part in this configuration is the formatter, right? And different services might have different formats that they accept out of the box, right? And the library comes with two formatters already, one for Datadog, that's the one that we use, and another for Google Cloud Logger. But you can easily write your own formatters. It's just a behavior. We write one or two functions, and you just get the log data, and then you just structure it. It's really simple. And then, as a bonus, they have this plug that you can put on your endpoint module, and you get extra information about your HTTP requests. So yeah, it's straightforward, right? It's a few lines of code. And just by doing that, so we go from a structured unstructured log to a more structured log. So we have these JSON objects that we can easily ship, for example, for Datadog or whatever service that you might be using. And there we can just index certain fields. We can process on different ways. So for example, this is a concrete example from Datadog. It's the vendor that we use, but this is applied pretty much for everything. So we have some unstructured logs. We basically just get the text. It's not really relevant, the text that is there, but it's just the format. And the searches are really just full text search. It's not really interesting. But with structured logs, Datadog actually understands this structure and gives you a structured view of things. You can index stuff. You can filter by stuff. It even recognizes like the PID, so you can filter by the PID and all the logs that are in this process. That's kind of cool. So we just, a thing that took like 5 minutes, we have this massive upside, right? So we can now index stuff, we can query, we can do a bunch of stuff. So yeah, considering that we are a startup, we move fast, I think that there's no excuse for at least not try this. So, okay, cool, this worked for us. So now we have logs. We have these kind of disconnected things that we can parse, we can query. That's fine. So we thought to ourselves, so where do we go from there? So, okay, so it would be nice if you could like connect things together, right? So that's where tracing actually appears. I'll not really go deep into OpenTelemetry. I think there's other talks about it. But basically, OpenTelemetry is just a set of APIs and SDKs where the idea is that you instrument your code once, and you can export your telemetry data to any other service that complies with OpenTelemetry standards. And the configuration is also very simple. So you have a few libraries there. There's other libraries that provide out-of-the-box tracing. For example, OpenTelemetry Ecto, OpenTelemetry Phoenix, but you have things for like Oban, for Tesla, all this kind of stuff. And you just, in this case, you just initialize things on your application module. But with this, you get a few out-of-the-box tracing, but the real magic here is when you instrument your own code, right? So you just like require the tracer from the OpenTelemetry SDK, and then you just add this with span, so you create a new span wherever you want on your code, and it automatically just joins it with the parent span or trace that's in the context. And then you can have these set attributes and set stats. That's where you add your dimensionality, right? So this high dimensionality thing that we want, we can add as much context that we can just to provide these breadcrumbs of information that later we can use to ask questions. That's the goal. So we want to be able to ask any kind of question. And it's easy, right? A few lines of code. So we thought to ourselves, okay, so very minor investment in time, we can have a huge upside. And for example, for us, this is just a quick example, again on Datadog, we get these flame graphs, we get on the bottom, there's a pane with the attributes. If you see there's like a reddish black box there, where we have an error on that specific span. So it's very easy to like visually just see an entire process and see, okay, we are erroring out here, we are spending some time in here more than we want, so we can focus on that and look into it. So again, very small investment in time, huge upside. So we like this. And I'm showing you here Datadog, but the cool thing about OpenTelemetry is that you might even send this tracing information for many vendors at the same time and just compare, see what fits best for you or your use case. So it's pretty flexible. And also, the cool thing about the OpenTelemetry SDK is that it adds the span IDs, the trace IDs to your logs. So if you send your logs and your traces to the same platform, it could be Datadog or Google Tempo, Grafana Tempo. Basically, you can use these IDs in the logs to correlate things. So now you can, from the traces, go to the logs, and from the logs, you can go to the traces. And you keep asking questions to try to figure out what's going on with your system. So this seems to make sense, right? So it's very minor investment, huge upside. Okay, cool. So we did this. We're fairly happy with it. And then we started, okay, how can we even improve a little bit more? So in parts of our application, we use CQRS and event sourcing with Commanded, and they already have this notion of correlation and causation between commands and events. And we looked at this, and okay, this is kind of cool. So, for example, this is just an example of what correlation and causation is, and you see that there's A, B, C, and D that might be different tasks or flows in the process. It's different things, and they all have the same correlation ID because they're all like the same logic, the same business logic flow. And then you have the causation ID that tells you what caused what. So B was caused by A, C and D was caused by B. So this is, just a simple explanation of it. So we looked at it and we said, okay, this sounds interesting. We have it on the event store. So how can we expand this idea to other places? Because we thought this was a cool idea. So, okay, we have a few asynchronous processes with Oban that gets triggered by some event handlers. And that would be cool because we want to correlate those asynchronous processes with other commands that might be dispatched or other asynchronous processes that get triggered by those jobs. Okay, so we thought about it a little bit, and we added that to our O1 jobs. But we still needed a way to actually view this, because at this point, the event store was a black box, and looking into it was kind of hard, right? Just doing the queries directly in the database wasn't the most interesting thing. So we actually built our own thing, our own tool to actually look into it. So we called it Watchtower. And on this image, you see we are just introspecting an O1 job. And we have all the details that we need, like the information about the job or the arguments, the metadata, any possible error. But I think the real nice thing is this correlation graph that you see at the bottom. So this is done with Mermaid.js, and the whole application was done with Phoenix Live View. And Phoenix Live View was actually a very nice thing for us because we could easily and quickly just create this application that we can do queries, can just move between different pages of results, go inside, inspect stuff, and look for the problems and look for the details that we need to go after a solution. And I have an example in here of what is a typical investigation done with Watchtower. So we could just search, in this case, a pocket with money, and we look through the list of events. There's pagination. We found like a weird event in here. There's the correlation graph. We could just go around, look into it. You can even click on other stuff. So we have this color-coded. So the yellow things are commands, the blue things are events, the green things are asynchronous jobs. So yeah, this has been a very valuable tool for us because it allows us to quickly dig deeper into what we have as a black box, like this event store and then the asynchronous jobs. It was kind of weird to find things in there. Cool. So what have we achieved with all of this? So this has definitely made it easier to just scale the application and just speed up the software delivery process, because it not only this helps us in production, but also in the other environments, like the QA environments, the staging environments, everywhere. There's no more need to add extra instrumentation to find new scenarios, because we started adding all of this context to these events, and now we are pretty confident that any problem that we get, we can ask the right questions and get to the bottom of it. Also, kind of a side effect of this is this democratization of access to the data. So anyone at the team, even if they are new to the company, they are comfortable looking through this data and investigating, asking the questions, understanding the system, and even solving problems. And those charts that you've seen there in our tool actually are very helpful to talk with like new joiners, to make them understand some complex processes that you might have with like event sourcing. It's by itself, it's can be a tough topic, but if you show them something visual that they can understand and follow through, yeah, it helps in the process of the onboarding. And also, it helped us measure the impact of our changes, so we keep deploying, delivering new things, and we keep track of how they affect the system, good or bad. Yeah, just this is a journey, right? There's the objective, but never the end. So we always have next steps. So for us, the next steps are to increase and improve the usage of service level objectives that we are kind of starting right now, working on it, being able to define them better, to use them better. That's part of the process. And also this concept of error budgets. This is something very interesting, but we are still very new to it. But the idea is that you have an error budget for, imagine in a month, you can have 1,000 errors. And you can measure your current error rate. And if you see that your current error rate, you'll expire your budget in 2 hours, you are in trouble. You need to wake up at 3 a.m. to go fix it. But if you are expiring your budget in say 2 weeks, okay, that might not be as priority. For now, you can put it in your sprint, work on it as you see fit. So we are still very new to this thing. We still want to learn more, but it's something that we are definitely interested in. Also, we want to expand the usage of the correlation and causation identifiers across all services. Right now, it's a very a proof of concept. For us, it has been working, and we want to expand to other areas of our product. So we really want to go after it. Also, we would really like to make our custom tool open source. It's still very tailored to our needs, so we are not sure how can we do that. But if it's something that might be interesting for other people to use them in their companies, that might be something that we want to look into, because I think it helped us, might help someone in the community, and we want to give back. So that's something that we want to do. And also bringing the observability to other realms of the engineering process, like CI/CD pipelines. We want to know error rates, times, and where we can improve, like other pieces that are not like the production clusters, right? Just to finish, I think these are the main takeaways that I would like to pass to you. Is this, you can adopt observability early in the project, and it's not as big of an investment as it might seem at the first. You can actually do this while you are bootstrapping the project. It's some of the things that you can put in place, and they have such massive upside that will help you a lot. It's not perfect, right? But it's a beginning. It's a nice place to start. That's the second point. You have incrementally improve and find new ways of adding to your process. And the last note is that custom tools may be good for your domain, but always think about the costs of developing and maintaining them. So think about it. If it makes sense, okay. So I think that's it. So thank you.
Thank you, Daniel. We have time for a couple of questions. Do we have any questions in the room?
Thanks a lot. Really enjoyed the talk. So it was a journey. If you were to repeat it again, what would you do differently?
Yeah. So the question is, it is a journey, right? And what would we do it differently from now on? Definitely do it sooner. That will help a lot. Because we started when it's a startup. You start, you move fast, you go do it, and you learn about it. And definitely from the day one, the day that we bootstrap the project, if we set up the libraries, the logging, everything is done. We just add instrumentation to the code, so it would be much easier. Because the investment is the time investment for this is kind of low, but the upside is so big. It's so huge. It's helped us a lot, really.
We have another question over here.
Thank you for the talk. And my question is, have you considered using Erlang's telemetry library, because it has already integrated support in Phoenix framework, Oban, etc., and easy to use, and in conjunction with separate libraries for integrating with Prometheus, etc. And if considered why you picked up OpenTelemetry over it, and when you would recommend to use Erlang's telemetry?
I'm going to be honest, we didn't look into Erlang telemetry libraries. We went with the thing that made sense to us. Like OpenTelemetry made sense to us because it was vendor agnostic, because right now we are using Datadog, but we might want to use something else in the future. And having that possibility was very enticing for us. It was very important. So I think the main reason why we went for OpenTelemetry is because we didn't have that vendor lock-in, and it was easy. It was right there. So I think we didn't really explore many more options. So sorry, I don't really have a good answer for you. But OpenTelemetry worked for us, and it's been good. We have been liking it. Yeah. Cool.
Do we have more questions?
Here. Thanks for your talk. Is there using OpenTelemetry, is there a way to get the metrics as well? from data, at least Datadog that you're using?
Yeah, on the like specification, because OpenTelemetry is done, it's been managed by the Cloud Native Foundation, I think. And on their website, they have like this, how do you call it, maturity level for the libraries. And for Erlang and Elixir, it's still very mature on the tracing part, not as much on the metrics, unfortunately. So we for the metrics, we just send them directly. We use telemetry, the telemetry module from Elixir. We basically just send them through statsd to the providers. But it would be cool. I would like that as well, to use OpenTelemetry for all of that. It would be very nice. Yeah.
We have another question from the conference app, and that is, are you also planning to add system inherent anomaly alerting?
No, right now, but we can look into it. It's probably interesting. Yeah.
Okay, we have time for one more question. Do we have one more question here in the room? I don't see any questions. Then please give another big round of applause to Daniel Silva.